I'm getting better, maybe. I just arrived from China yesterday night, midnight. Yeah, it was. They have amazing people. Yeah, and I learned a lot from them. And they are huge on AI. And they spend a lot on AI. Same as India. I think India is also parallelly competitors, close competitors with China.
The recent news are out that in coming future, Indian
Yes,
people will be the hub of AI.
correct, correct. So Indian and they won't lose to China. China won't lose to India. So they fight together. Thailand is become pieces. No, no. But what I'm trying to say is that if you guys stick with I think it's the correct choice. It's a very good area of studies. But of course, it depends on whether you like it or not. If you don't like it, then there are so many areas of research.
Maximum research is going on in China and Hong Kong.
Yeah. Right?
All the papers are.
All the good one, right?
Yes. Yeah. All medical, even DPI, most of them are. They are introducing everyday money.
So how was last week that I'm not here? First is the quiz. Manageable? Manageable? Okay. And you guys learned instruction tuning.
Vision transformer that is out, that is residual vision transformer.
Residual vision transformer. Okay. Yeah. I think we just read roughly and try to think how we can be new a little bit for your PhD, right?
No, this residual vision transformer is not used in residual.
Oh, then you can adapt, right? Good. Then that is a novel.
There is one thing that there was one seminar online. I don't know. I don't remember the name of the company. They are doing the AI radiologist, and they have around 3.5, 3 million of images.
Right.
And all that stuff. So I went and met that lady. So she said that if you want data, you can go for Mahidol University.
That's perfect.
They have really a lot of data.
And you can contact them, you think?
I don't know, like I don't know them. But yeah, they said that is one of the biggest hubs when it comes to the medical imaging.
Oh my goodness, please connect us to them, okay?
So that is it. REST VIT is one thing that is like it is used in the medical field. Image image recognition recently, but it is not used in, and it is outperforming the traditional view.
What is the main idea?
It's basically the main idea is that just vision transformer, like once it goes out, the gradient is visually it vanishes. To just to compensate that, they are using CNN part that the residual part has a token, embedding token as a residual token. Then they are passing it.
I see.
So it's like
not easy, not difficult to implement, and also very easy.
Yeah,
makes a lot of sense.
Yes, because it is saying that if you see the clip also, if you're seeing clip also, they are using ResNet 50. They are using vision transformer. There is one more of vision transformer also, but they are using ResNet 50. Even the recent one is using ResNet 50. So this is the new model that is out, that is in combining ResNet and vision transformer together. And it was in my mind, but I don't know whether it's like it was the right idea or not.
Okay. Good. How you doing? It's currently NLP. Tomorrow it's HCI. But you can stay here. Yeah. You can sit. It's Monday, it's Tuesday, whole day, and Thursday morning.
Tuesday whole day?
Yeah. 3 hour block, 3 hour block, 6 hours. Yeah, because it's a short course. HCA is a short course. Yeah. Go inside? No. Oh, please come. How's everything? Instruction tuning, okay? Chris, okay? Okay. So you want to talk about it today or maybe after class? Oh, you mean the... How are you doing? You you thought today is HCA, right?
Yeah, because I'm quite depressed. Because last week I meet a phone,
Yeah.
and then see you need some feedback.
You want to talk to me, right?
Yeah, but because of the feedback, so I tried to show some loss and I got depressed. So I thought today is like SCI class.
No, don't depress.
Because she said let apply SPN like some model. I don't.
I think she want to use that software. It's a software called Etsy. Yeah. Yeah. That software can create a system modeling. If you want to learn that, you need to watch maybe 1 or 2 YouTube video. You should be fine. I I think I have tried one time. It's basically SPSS and JSP, but put it into picture, and people like it.
But I don't know why I need to do that.
Simply because that one gives you a very high power statistical confidence. Yeah, those kind of analysis, and it can create bilateral relationships. So it's auto. So you just put in the software and then just click boom, it gives you all the numbers. And that's why I think if we are not good in like statistics, we just use that software. Yes, that is the idea. It's more powerful than JSP because JSP you need to manually link which direction, and not it's not uh, well prepared for beginners. Yeah.
It's like so for example, my hypothesis factor A will be factor B, right? So I just use one habit alone
I think Watchupon is Dr. Watchupon is maybe interested in bi-directional, right? Really, which direction affect which direction, right? We have to make that one clear. Otherwise, you cannot defend, right? Yeah, her question. Anyway, we need to do that. Yeah. But her point is very good. Yeah. Okay. Yeah. So try to explore that too, as you mentioned. I have tried before and it's very powerful. And it's there's a if I'm not wrong, it's a free trial. Yeah. Enough, more than enough. Yeah, you don't need to be here. I can manage it because there's not much assignment. It's mainly workshop, right? So you just whenever you can come, you can join. Okay. 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 Yeah. All right. So welcome everyone to back to NLP class, and I think I miss you guys, and hopefully you also miss me a little bit. Yeah, actually, I can make some excuse that I actually went to uh, China for my mission to promote data science and also to learn how they teach AI and data science. And I visited uh, almost 15 universities in China, including the top one. Yeah. And there's so many things I can say. You can come and talk to me. But I would say first, China, I also near India, uh, has probably put all their bets on AI, right? But their perspective on AI is not only on AI itself, it's also applicable to other areas, right? So every areas is AI oriented. So I would say that if you really enjoy this area, I have the confidence that please keep doing this area. Even though Thailand, it's a pity that Thailand is still very far behind our neighbors, but I can confidently say that my lecture, particularly my lecture, is not so far behind. I actually teach very, uh, at least more recent, right? Compared to, let's not compare, but I can confidently say that my lecture and all the labs that we give actually prepare you to fight with the world. I don't care about you fighting in Thailand because there's no battle in Thailand, right? Thailand is very new. We are very far behind. So there's very little competition. But I care that you can compete in the global stage, right? And I believe we can. But anyway, my first point is I can confidently say that if you enjoy AI, please work on it. Yeah, there's a lot of jobs. Unfortunately, not in Thailand, simply because Thailand only care about, oh, China, you have technologies, I buy. India, you have technologies, I buy. Because Thailand is so far behind. And I'm not talking about only Thailand. I'm talking about all the ASEAN countries, right? And there's a lot of catch up in ASEAN. And also Nepal. I'm not sure. Nepal is like, they are doing a lot, but I would say Nepal and Thailand are in the stage of catching up, right? Also, Indonesia, we are catching up. Vietnam catching up. Bangladesh, we're catching up, right? But India and China is like completely in their level, right? But anyway, again, coming back, I want to reiterate that AI is such a good area, right? The second point I want to say I learned a lot is that only learning AI is just a one step of your journey. The second part is the domain knowledge. You need to know how to apply what you learned in my class to solve problems in the real world. Finance, banking, socials, issues, security, space. China talk about space, water, material science, right? So that is the second part that you guys need to fill in, right? If you only know what I teach you in the class, you only have the half part of the success. If you know another half, it's perfect. For example, one of the students here is working on medical, right? Then you need to have a very deep knowledge, not deep as doctors, but you need to have essential knowledge in medical image, right? Another student sitting here is working on brain-computer interface. So having knowledge in how brain works is essential, right? So combining with AI, you can earn a lot of money and create a lot of impact, right? But if you only know AI and sitting in your room only coding, of course, it's better than those who don't know anything, like zero. Then it's better than nothing. But I would say that I would talk to people who already good in coding, add this domain knowledge that would make you a perfect. Yeah, you can fight in the global stage. And also, lastly, this is just a very general recommendations. Of course, I myself have a company in Thailand, but I would say that for those who have very good skills, you can do all my labs. You feel like you can do all my things. You understand what Chucky teach you. I think you're ready to fight in the global stage. You should try to apply jobs in, let's say, okay, China, you don't know Chinese, right? So it's difficult to you to go to China, but Singapore, Malaysia, Vietnam, those countries, they are invest a lot in AI, right? Try apply jobs of them, and you will be well received if you really know what you're doing. If you can do my labs, right? Then I think you can apply jobs and get very high salary. I go to Macau, professor in my status, teaching AI, earn 3 to 4 times more than me. Yeah. AI engineers, like you guys just graduated, earn 3 to 4 times more than you will earn in Thailand, right? So it's Macau, right? So of course Singapore and Malaysia they earn a lot more than Thailand, right? So I think that is my last thing point of course there's so many technologies, but let's not talk about technologies. It's all in the lecture anyway. Yeah. Yep. Okay, great. So that is my summary. Hopefully, I make my excuse and give something back of my absence. But yeah, I really enjoy my visit to all these Chinese companies. Okay, so let's come back. Project. So we have projects coming. So there are many things you need to do. First, you need to know when you need to present your project proposal, right? So please take a look at the calendar. I think Tasawat will remind us again when exactly is the proposal, but let's say he forgets, you should also know like, okay, next 2 weeks is our proposal, right? And then you should prepare proposal. There's no format of what you need to propose, but I would say that as commonly thinking, right? The proposal should have uh, background, we should have the problem, right? Mainly the problem, right? Like what is your problem and motivation? And then you should talk about related work, right? So each of you should read at least two paper. When you read paper, there are two types of papers you can read, fundamental papers and applied papers. Fundamental papers is good when you do research, but here the project is very short, right? So you may want to balance yourself like, okay, I'm gonna read one fundamental paper and one application, applied papers, right? If you read all fundamental, you don't know, check it. I don't know how to make the project because you cannot pre-train, right? Pre-training is a fundamental papers. You want to read some papers that is applied to certain area, right? That is like fine-tuning paper, right? So you need to balance yourself, right? And then of course you need to talk a little bit about your like idea, right? You don't have a very good idea of your solution, but you can definitely talk a little bit about your solution that you want to come out, right? I don't know the time, but we have probably not too many groups, so we can do 15 minutes, right? That should be a good time. Let's say 10 to 15 minutes. And then that should be a good amount of time for you to express your idea. And then I and John will give you some feedback, right? So that is the idea. But anyway, project is very short, so it's mainly that my purpose is give you some quiet time to think about all this knowledge you learn. I don't want all this knowledge you learn just say, oh, Chucky, give me, give me, give me. And then if you don't use it, it's no use. If you don't use all the knowledge I give you, it's no use. Zero, right? I think you guys can relate, right? Like if I give you all the knowledge and you don't use, it's no use. So project is a quiet time you can think about things, meditate a little bit, and then learn how to apply. Even a little bit is okay, right? And if you really enjoy it, you can do your thesis 1 year, right? Yeah, at that time you have all the quiet time. So that is the idea. The second thing, so first thing is making sure that you know when to present your proposal. And that would be my template, but please feel free to come up with your own template. Second thing is come up with your project members, right? Gan, what is the average size of each group? 4 to 5, right? So please come in. So please come in Okay, great. Can you hear me now? Okay, great. So we learned prompt-based learning, and so prompt-based learning is basically no fine-tuning. The solution is to solve the model is too small, too big. PFT is when you fine-tuning, you want to make it easy to fine-tune. We also learned about the first application, that is question answering, right? So for those who want to do sales assistant, you need to learn how to do the RAG, right? So retrieval augment generation using LangChain. Today I will teach you summarization, and I think you already learned instruction tuning, right? You have to understand the essence of instruction tuning. What is the problem of the normal fine tuning, and why do we need to have instruction tuning? Can anyone tell me? You already learned from him. What is the essence? What is the difference between instruction tuning and fine tuning? Good job. Good job. Can you hear that? Make sure you understand that, right? I think you all understand that, but you are probably thinking, right? The normal fine tuning is task specific. You can only do each task, right? Which is ineffective, right? And every time you do new task, you need to fine tune, fine tune, fine tune, which is not effective, right? But it's effective if your company only care about that task, it's okay. But ChatGPT, people in OpenAI, they say, I want to create a general model that can do everything, right? If you want to do everything, you cannot train one by one, right? Then they do something called instruction tuning, right? Instruction tuning is every task can be in this format, right? Instruction and answer, right? Every task, every task in this world can be in instruction and what? And an answer, right? Then you combine summarization, question answering, translation, all in this format. Then you can train a global model that know all. This is the essence. Right. But of course, today we're going to learn summarization. We still have multimodal learning, analysis of model inner working. And if I have time, I will also teach a contrastive learning, which is very important. Great. So let us move to summarization. Great. So today we're going to come back to summarization. So last time we learned so many models, so many techniques. The first application we learned is question answering, simply because it's the most it's what ChatGPT is, right? Question answering. But today we're going to work on another area. It's called text summarization. My lab have many areas of research. First is the medical visual QA. Another is brain-computer interface. But another one that I work very heavily is summarization. Why do I like summarization so much? It's because it's an area that is still not perfect. It's still not solved. Machine translation, is it solved? A little bit, right? You guys already have Google Translate, right? It works quite well, even for Thai, right? It works quite well. But if you try summarization, it's horrible. It's still horrible. You feed a lot of document, summarize, is no use, right? If it's already solved, Google will not wait. Google will just create a Google summarizer, right? You input something, it summarizes, right? No, not yet. So summarization is a very good area of research. That's why I work a lot on it too. Yeah. Yep, and I think we are right here. Yes, summarization. So let us do some recap first. So the summarization fall into the areas called natural language generation, which refers to anything that we basically generate new text. It can be encoder, decoder, or it can be decoder. Of course, can it be encoder only? I don't think so, because decoder is the unit that generate text. And NLG can be done either via language modeling or conditional language modeling. Can anyone tell me what is the difference between these two? Language modeling and conditional language modeling. Which one is a decoder only? Which one is decoder only? One or two? Which one? I have two choices, mix and match. Decoder only and encoder decoder. Which one is decoder only? One or two? Decoder only. Decoder only. One. Language modeling is predicting the next token, right? So there's no encoder, right? There's no condition. ChatGPT is like this, right? Even you prompt, the prompt itself is inserted into the decoder, right? And then it just generates the next token. So decoder only is language model. They're the same. They are basically decoder only is the architecture, and this is the us, right? That it pre-trained on. Conditional language modeling is basically the task that encoder, decoder do, right? The encoder is the condition, and what it decode is the language model, right? So please remember this two term. So the language modeling is basically predicting the next word, and it can be formulated in this equation. An example of language modeling task is writing story and code generation, simply because they are not conditioned on something. You can say that decoder only can condition on something because you have prompt, right? But the word condition is basically you have a separate model, separate encoder that actually encode this condition, right? That is like the meaning of a conditional language model. So conditional is basically you have you want to predict the next token condition on X, right? So the example is a machine translation. You have X, right? This target sentence depend on this X. This summarization is dependent on X. This paraphrase sentence is depending on X. See? So this is the idea, the meaning of me saying conditional language model. It's depending on something. Yep. Don't be confused with ChatGPT. You may say ChatGPT can do all this. Yes, but then where is X? X become the prompt, right? X become the prompt. So in that sense, it's still language modeling, but the condition, there's no more condition, but that condition become the prompt, right? So don't be confused. But of course, there's so many terms and there's so many overlap things, but I hope you understand the essence. So if you draw a conditional language modeling in INN architecture, then the encoder is what holds the condition, right? What you want to condition on, the target sentence, and then you also have the decoder, which is output depending on the condition, right? So this is basically the conditional INN. Transformer, can it be conditioned? Definitely, right? Because in a transformer, in a transformer, in a conditional transformer, is basically this, right? This is a conditional transformer, right? Which is what you learned in the Devlin paper, right, in 2017, right? They actually is conditional transformer because the output is conditioned on whatever the encoder gave you, right? But can transformer be purely generation? Yes. And it's basically removing this, right? If you, oh, maybe I don't delete this. If you simply If you simply delete this part and delete this, this is language modeling, right? And this is ChatGPT. This is GPT, right? Just now, if we have two modules, the most famous model is BART, right? Encoder, decoder, right? But if we cut the encoder, the most famous decoder-only architecture is GPT, right? So there's a lot of things mixing here, but make sure you understand all these concepts. Otherwise, you cannot satisfy your boss. Yes. We also talk about decoding algorithms, right? Um, so decoding is basically how we generate the text, right? But decoding is just another word for inference, right? Decoding is basically another word for inference. What is inference? Inference is a real-time inference, right? It's not training. So decoding is nothing about training, okay? During training, you use teacher forcing, right? Basically, you make sure that this guy predicts the next word, right? But decoding is during inference. When you inference, the model can output so many things, right? How do you output, create diverse message, right? That is another things that you need to consider, right? Of course, you may say that if you simply take the argmax, it's called greedy decoding, right? Which is work well in machine translation because you only have one definite translation. But we also learned beam search, right? Beam search is another good inference method that you can get many sentences and it can choose the best sentence out of that. But what we haven't talked about is other better technique than beam search. I myself has a lot of trial and errors with all this technique. I found beam search somehow doesn't give me good results usually. I'm not sure you guys, anyone try playing around with beam search? Top K, top P, no? Okay. I myself tried and I don't feel like beam search is a good way. Beam search has this problem that is um, when you try very low beam size. What is low beam size? Low beam size is basically one sentence, right? Like just one sentence. So it's basically argmax, right? And because of that, you usually give very like on topic, like very strict, but usually may not be I love to eat healthy and be healthy, right? This may give you the highest probability, right, from the beam search, but it's not like a good candidate. Um, and high beam size, whenever you have many very high beam size, you search the best solution. But the problem is you will get a very good sentence. What do you do for a living? You get a very good sentence because you search across all the possibility, right? But because you search for all the possibility, you will always get one sentence that is the same. Because this is like, if you answer like this, there will be no wrong. So you sacrifice diversity when you have very high beam size because you search the optimal solution, right? Optimal solution, the solution will be small and small and small, right? Then you only have only one sentence, right? That means your answer will be less diverse. So the question is the problem of beam search is this: you don't know what is the best beam size, right? Then this is a problem, and we don't want to think about it. So yeah, of course, this is something I already talked about. Small k is basically like greedy decoding. If k is equal to 1, it's basically argmax, right? If you have many k, then you also have a lot of problem, right? Basically, diversity and also computational expensive. So this is also another problem. So I think actually I already hinted other ways that you can do better, right? Firstly is sampling. Did you guys do this in your homework? Right? I think you guys do this, right? Pure sampling, right? But pure sampling is perfect. But what do you think about pure sampling? Is it a good way? It's actually a very good way, right? Um, but there's one problem that sometimes is it possible that you sample very low probability? It's possible, right? So people say that why not we restrict that we call something called top K sampling. We only allow the model to sample from the top K distribution. For example, I would say keep the top 10, I will only sample from the top 10, okay? That is what top K sampling is. But what is the problem? But what is the problem? The problem is if you have this kind of distribution where there's so many candidates that are very competitive, and you just say, I want 10. If you just say 10, oh, if you just say 10, then there's so many other candidates that you just cut off, right? Do you guys understand my point? Another problem is, wow, you look at this distribution. It's definitely hot and warm, right? There's no other choice. Other choice doesn't make sense at all, right? Do you need to do top K? You don't need. You should only use top 2 here, right? Because the probability is like hot is like clear winner, right? So what top K doesn't work because you don't know where to cut. Do you understand my point? You don't know where to cut. So top K sampling is also not so good. So then you may ask, then what is the best way in the industry? I would not say best way, but this way makes a lot of sense. It's called top P. So what is top P? Top P say that I want 50%, let's say 50%. Then what it does is it will only get the 50% cumulative mass. Okay? So for example, this is the 50% of this whole distribution, and then I will sample from this 5 guys. Or this is the 50% of this whole distribution, I will sample from this 10 guys. Oh, this is the 50% of my whole distribution, and I will sample from these 2 guys. Do you understand? It's like you automatically set the threshold for cutting, right? And which is much better way to do it, right? So what is the current way you can work with? The current way, when you load a pre-trained model, you need to combine top K and top P. Understand? So you need to do top P and top K together, okay? So I would say this is like a practical, when you load a pre-trained model, use these 2 together. How do you do? First, you set the top P. Maybe you say 90%, which means that you get the 90% mass. And then for the top K means that if this is the 90%, you want to pick the top 5, right? Then you say 5. This will give you that, understand? So you combine top P and top K. This is the usual way you do. I will say again, top P will restrict the mass that you will select from. And top K is that from this mass of selection you already give me, how many rank you want me to sample from, right? If I say 5, that is 5 from this 90%. Yes. So this is a common way you use in the industry. All right. So make sure that you know this in the real world. Yeah. Of course, what I teach you is only by the year of 2020, 2021. All right. Is there any other way that we can do this? Oh, so many ways. For example, Gan, his thesis is on perturbing the distribution to do privacy, which we are semi-successful. Sometimes we fail, right? It's not an easy task, but there's so many ways you can imagine, right? There's so many ways you can change this distribution, right? So that you can focus on maybe a lot of word is like eat, ate, put the food in the mouth. There's so many ways you can talk about eating, right? You may force, you can change the model such that you can look at distribution and tell the model, create another model and rank the sentence. I want British way of talking. You understand? British style. Then you can re-rank the sentence and talk British way. You can do this. This is called, I'm not sure what it's called, but it's doable. So you got this distribution from the model, you re-rank it using another model, right? Using some British model, right? Or maybe Thai model, Thai English, I don't know, right? Then you can re-rank this distribution. So there are so many ways that you can work on this area of research. So very, very interesting. Another thing that you need to know in the industry, of course, Chucky did not teach you all the recent papers, but this one you must know, right? Which is a softmax temperature. It's something that everyone uses in the industry. So we call this. I think you guys are familiar with this, right? Can you guys take a moment to remember recall what is this equation? Yeah, it's basically softmax when you output the token, right? But sometimes when you do this, you'll get a distribution that like this. When I say distribution means that, oh, this wood could be hot, right? Like the highest probability, and maybe this is a warm, this is a cold something, and this is like chucky, like no use, some word that probably would not be the next token, right? This is distribution. But sometimes there are two things you want to do. First, you want to make it sharper. What do I mean by sharper? It means that you make it like this, right? Like just one word you want it to output. Or maybe you want to make it flatter, right? Flatter, right? So it maybe like this, right? Then more words can be output, right? When do you want sharp? When do you want flat? Sharp when you want to be very specific on what you want to output, right? Like it's a very strict conversation. Like you only want it to output like this. When do you want diverse? When do you want to flat? When you want to talk very creatively, like story. When you want the AI to make Harry Potter, right? Then you want it to be very diverse, right? Then you want to flatten this plateau so that there's a more chance many words can come. Do you guys understand my point? Yes. Then how to do? Well, in today's world, we kind of figured that out. That is just divide by some term. So simple. You guys get the idea, right? If you divide this term by a very big number, if you divide this by a very big number, it becomes flat, right? It makes sense, right? Like very big number divided by a very big number, it becomes flat. If you divide it by a very small number, like less than the one, then that it become spiky, right? It makes sense. So you all need to know this technique. But in practice, what I found the problem is when I code, I don't know the best temperature. And all my students always check it. What temperature to use? I can frankly tell you no answer. Okay? This is the problem. We only know it works, but we don't know what is the number like 0.3, 0.4, or 0.9, right? Then I think I have two choices for you. One is read papers and copy them. Or maybe number two is if you have the time, if your boss is very patient, then you just keep changing the temperature and find the best fit. Okay? This is like my personal experience, like not theoretical. Yeah. Yeah. Great. Who say AI is difficult? I think this is quite relevant and practical, right? And then I hope that you can enjoy that. Yeah. But of course, to combine all the knowledge into one project is not easy. Summary for those who are lost and sleepy. Now is the time to wake up. Greedy decoding. No, we don't use greedy. Beam search. We don't know the beam. So not so good. So the problem is the beam. Yeah, sampling is probably the way we want to do. We have top K, but the problem with top K is we don't know the K, and it's cut off too quickly or too early or too slow. Then we combine with top P, right? So top K and top P combined together, you get the best results. But still, you will all have to face the same problem I do. Check it, tell me what is the P, what is the K. I also don't know, okay? Then what do? You read paper or you just try and earn. That's why I want you guys to start your project quickly, okay? Trust me, you don't load the model and just make it. No way. You need to load the model, try all these parameters, right? And then you need to understand why that parameter also works. Yeah, sound max temperature is a very easy way to control diversity. And by the way, I forgot to say that this is represented by a symbol called tau. Tau, right? It's like a T. Tau. Yeah, this right. It looks like a J, but it's called tau. And you may say, why use this to represent that? I don't know, maybe T and T, okay? That's it. And it's just a number. You don't need to worry like, Chucky, why is so special about this notation? Nothing. Yep. So I, there are two groups of students in my class. First group, you only want to finish my class. Then, yep, I think in the beginning lectures are already more than enough for you. Second group is you only want to work in the industry. Like, I just want to quickly graduate from AIT, bye-bye AIT, and I want to get some work. Then you need to code a lot and then learn the essentials, right? And make sure that you learn all these things, basic things that I taught you, and code a lot. Trust me. When you work in a company, people don't give you time for coding. And they don't care whether you are junior or whatever. They just expect results right away because currently the world is very competitive and the economy is not good. You understand? So they don't give anything like, Russia, you okay, I give you time. No, there's no such thing, especially in a very competitive environment, right? So you just go in, make impact. Right? Otherwise, you're gone, right? But for those, that third group of people, that is, you want to be not only working in a company and do your daily job, you want to create a huge impact in your company, right? You want to create something very good, not only a simple summarization or simple question answer. You want it to be better, right? Then you need to learn to read papers because only papers contain all the new technique that can make your work better. You understand? Yeah. Only using all this technique will not make your model good. But reading papers will get you all this knowledge to create good impact on your company. Yep, and of course, yeah, teacher forcing is still the only way to training. But have you guys ever questioned, is teacher forcing the right way to train? And I'm not sure, right? Like you try to force it to predict the next token. Is it the right way, right? Because the big problem is diversity. Right. Okay, great. So no, we're not finished today, okay? We still have a text summarization. But firstly, are you guys tired? If not, a little bit, okay. How about we have 5 minutes quickly break, okay? And then we come back, yes. How are you? You okay?
I filled the form that he gave.
And I'm not sure Joe told you. I plan that you can work with Professor Sewa.
Sean,
Yeah, Sean. Uh, and then he never do research fellow, but he has very deep knowledge on EEG, right? You have, we have very deep knowledge in research fellow, but we have crap EEG, right? So I told him to work together.
so we go there.
Yes. So sometimes you may need to go there, but you can reimburse all your transportation. Right? Understand? Yeah.
But it's very far. It's 60 kilometers.
Yeah. So maybe you just go there once in a while. Just use the head to get some data. Yeah, something like that. But he's very happy to help us. But I'm not sure Joe tell you.
I already filled the form for that.
Oh, okay.
And he gave me the input about using SAT test. I also filled that in the form.
Okay, great.
Now we use SAT test, not only anybody, but only people who pass the SAT test.
Okay, that's perfect. Yeah. All right, so let's come back to text summarization. So I got a lot of good questions, but mostly questions is related to projects and quiz. So firstly, quiz. Someone told me when is the quiz 3, which if I'm not wrong is the last quiz, right? And again, quiz is probably comprise a lot of points for your grade because we believe that quiz is something that you really do by yourself. So make sure you do it. So the quiz will be on April 1st, around that. It's probably Monday or Wednesday on that week, probably next 2 weeks. And the quiz content will be on instruction tuning and LLM. Okay, so those will be the area that we ask you to do. And any announcement on assignments?
This week is 4 number 7.
Okay. Okay. Okay, so this week is very, very interesting. Not sure you guys already know this week assignments. Anyone already see the assignment? It's an AIT GPT, right? So it's fantastic. So I can give you idea how to do it because we already do it. And it does not take a lot of time. Of course, if you want to make it good, you need to takes a lot of time. Idea is very simple. Let me teach you the way. First, you need to use LangChain framework. So watch some video and you will know how to use it. Second, you need to create a vector database containing all the information about AIT. So how to create this vector database? You need to crawl information from the AIT website. Each of the web page is a PDF. So you have many PDF, right? You input all this PDF into vector database using Python code. You can do the Python code and then just create the LangChain. The LangChain will say, then you need to choose a model that can answer all these questions based on the context from the vector database. So the model is usually ChatGPT or Llama or Mistral, okay? And then you just carry forward. But of course, if you want to work very deeply, there's so many techniques, right? Any other techniques you want to mention to them, that I missed? Or just this enough? Yeah, I think this is like basically that is. And once you create the AIT GPT, you need to put it on website. You can use a Flash, Streamlit, whatever. There's only 2 ways, Fast API or Streamlit. I highly recommend you guys be familiar with Fast API, but if you guys don't care about making application, just use Streamlit, right? For example, yeah. So that is the homework. Yeah. Anyone has any question on the homework? So those are the 2 questions I got: quiz and the home assignment A7. I got some question about the project. Like some people ask me, what do you expect? Like seriously, do I need to make it as an application? Firstly, I don't expect you to do like Google level thing. You cannot do, and no way you can do, okay? Because you only have 1 month, and you never do this, right? So my job is to give you a platform, all these labs, A1 to A8, to get you used to coding, and the project is just to apply that. Do you need to make an application? Yes, but the application no need UI. You don't need to do UI, okay? I don't give points to UI. You just give the input and output, finish. But I want you to deploy as an application, okay? So that is probably my point of the projects. Those are the 3 things I got from during the break. Anyone has any other questions you want to ask me? Okay, great. Okay, text summarization. We got 20 minutes left. That should be enough time to talk about this. So in summarization, you are given input text X, and then you are asked to write a summary of Y, which is shorter, usually shorter than X. And the input, when I say input text, it could be single document or multi-document. When it's single document, we call text summarization, simply. When it's multi-document, we call multi-document text summarization. Yes. There are many data sets that you can utilize to work on this task, text summarization. GigaWord. The famous one is probably CNN Daily Mail, because it's related to news summarization of this website, CNN Daily Mail. And XSum. Actually, I forgot to write one. There's one also called Dialogue Sum, which is a summarization of all the Zoom meetings. It's super relevant now. Super relevant. I think you guys use Zoom, right? And they give you summarization, right? Yeah. That is called, there's a data set called Dialogue Sum. I think Gan is also using it for his thesis. It's called Dialogue Sum. And also MaxSum. It's for dialogue. It's for Zoom meeting, Google meeting. There's a very similar task. It's called sentence simplification, and summarization and sentence simplification are totally different, right? Summarization is trying to get the main idea, but sentence simplification is just to write it in a simplified version, right? It's still totally different. For those, like I said, you can work in many labs, but for my lab, one of the area of research that I work in is summarization. And whenever anyone comes to my lab, I will always say that if you want a summarization, you need to figure out whether you want to do extractive summarization or abstractive. Extractive means you copy from the content and say this is the key sentence. Understood? This is called extractive summarization. You copy. You did not write it from scratch. You copy. So for those who can relate, it's basically squat. Remember I teach you squat? The question answering, the reading comprehension, right? That is basically very similar to extractive summarization, which means that you need to keep the start token and the end, I mean, not the start token, start index and the end index, and that is extractive. By the way, for extractive summarization, it does not need to be only one part. It can be start, end, and start, end, and start, end, right? Many sentences and combined together, right? So this is extractive summarization. Abstractive is more difficult, and this is the part that no human, let's say research community still cannot fix this. It's still an area of research that no one can do. It's basically generate from scratch and try to summarize it. And you can see that this area of research is very active simply because we still cannot do very well. You may say, Chucky, I think ChatGPT can do, but there's still a lot of problem, right? It's not give you perfect summary, right? Did you try ChatGPT? No. Another big problem of summarization is input. If you have medical documents, one history of one patient is like 50 pages. And if I have 100 pages, I have how many documents? Whoa, so many documents, right? And then if you input this, or the model cannot see all the token, then you need to chop, then cannot do. So this is also a problem. That is a token limitation, token length limitation. Because there are many people working on VQA or also medical VQA. Another areas that is very interesting currently in the research community is multiple image VQA, or basically multiple image summarization. What is it? So if I have many medical image, or maybe I have many image of many things, please please summarize everything and write a text. You understand my point? Yeah, so maybe there are many image about the brain, or maybe many image about, maybe I like a manga, I like a cartoon, Spider-Man, right? I give all the images of the spider movie, and then please summarize, and then summary. This is also a very big topic right now. It's called multi-image, and basically it's abstractive summarization. So but for those who want to work it in my lab, I think this is a too risky topic for your master degree. But PhD may be possible. You need 3 years. Yeah. Okay, great. So yes. So make sure you understand there's a two-way, extractive and abstractive. Yes. So I may not be so clear on this. So let me make it clear. For extractive, what is the usual way? They are usually two steps. All right. For extractive is one. What do? You have candidate sentence. You choose the candidate sentence. How do you choose the candidate sentence? There's so many ways, right? Maybe this candidate sentence has a very high correspondence with the summary, the trained summary. When you train, you have summary, right? And the text. So you can teach the model to know what are the good candidate sentence. And good candidate sentence can be decided in so many ways, right? One easy way is maybe it has a very high similarity with the summary. Number two, you need to rank, right? Because you cannot just put all this candidate sentence, right? It could have so many. So you need to rank. And how to rank? Again, so many ways. And one easy way I can think of is, again, it can answer some questions. You can turn the summary into question. And if this sentence can answer by the summary, then that could be a good sentence. Let me say again, you can turn this sentence. Let's say I have one sentence, I turn it into a question, okay, using a model. And if this question can be answered by my summary, that means that this is a good sentence. This is another way, right, that you can rank the sentence. But I would not go deeply because there are probably so many papers working on this, right? But I want you to understand the key idea that there are these two steps in extractive. How about abstractive? Abstractive, number one, also candidate sentence, right? But then what is the difference between abstractive and extractive? In abstractive, number two, you generate, but you don't only generate condition on this candidate sentence. Understood? So this candidate sentence is inserted into the encoder and the output is the sum. Yes. So this is basically like the two paradigm that you need to know. And I'm sorry that I could not summarize like all the 50 papers in the world, right? It's just crazy, but you need to know that roughly that there are these two ways that you can do around with summarization. And for those who want to work on your thesis, you can explore more. What if if we want to talk about the first paper that used some kind of seek-to-seek, I think you remember seek-to-seek, right? Basically encoder-decoder. And Rush is the first one that actually applied seek-to-seek to summarization. And it's basically similar to machine translation. Okay. But of course, when you plot the attention maps, it seems like there's some relevance, right? Russia has a high attention, right? Calls and call has a very high relationship, right? Against has a very high relationship with combating and terrorism, right? So we can say there's a little bit of relationship, right? But at that time, that's it. Because in 2015, definitely they are using LSTM, right? There's no other model. I'm very sure they are using LSTM, right? So that is the best they can do. But by the way, this is abstracted, right? This is abstracted. This paper is on abstracted. But one of the key paper in 2017 is by C, by a Stanford students, and is published in ACL, the best conference in the NLP, right? And basically, she said that why not we create a model that can decide when to copy and when to generate from scratch. Do you understand my point? That is, you don't tell that the model should be extractive. The model should be abstractive. You create a model that can decide whether it should copy or not. And it's determined by a symbol called pgen, right? So firstly, this is a normal abstractive. Normal abstractive. The common way you do, right? What do? You condition the output on the input, right? And then you do some attention, and then you predict your distribution, right? So it's purely abstractive. And C say, no, I don't want to do this because sometimes it's stupid. Sometimes we can copy, right? If we copy a little bit and combine with our scratch, we can get a very good summary, right? It's a super good idea. And this paper is cited so many times. And the idea is super simple. You may say simple, but of course, she's a PhD student working on like 6 years on this, right? So it's not easy. No, nothing is easy. Her idea is super elegant. So you got one distribution. This is the abstractive distribution that comes from a decoder, right? And this is basically this one, right? And you multiply with a pgen scale factor. And this pgen is basically in the value from 0 to 1, right? And also, you also have something called the context vectors, right? Which controls the distribution of all this token. Am I right? Right. So if you know that, oh, maybe this Argentina has a very high attention, then maybe I can copy that, right? I can copy that. Yes. So you also allow it to copy, and the probability to copy is basically 1 minus pgen. So you can say that this architecture can either generate from scratch or copy, right? Which is controlled by this attention. And this attention is basically, if whatever is high, that is copied. But now you may wonder how this pgen is being learned. And it's very intuitive. That is, pgen is simply a weighted, basically just send the CT from here, and ST is from here, and XT is from here. And then, so basically you create linear layers to understand that in this situation, should I copy or extract, right? And then you pass through a sigmoid. Why sigmoid? Because it gives you 0 to 1. right? So yep, and her model is super nice. It can learn to copy and not to copy in different situations. So the very highly cited. But even though I talk so much about this architecture, this model is in 2017, and now we are in 2014, right? 24, 14, 24. So what is the model that people use the most? And the answer is definitely pre-trained. So let me stop now and ask you guys, if I want to do summarization, and Chucky already teach you there are three architecture, right? Encoder, encoder, decoder, and decoder, right? So you need to map this out like this. I want you to do like this. Even you finish from my class, even I die and you guys still live, you can mentally do all this thing because I like to teach you the process how I think. So we have decoder only, encoder only, and decoder encoder, right? And we have abstractive summarization, and we have extractive summarization. Which architecture we can use, right? So if we want to do extractive, we can use encoder, correct? Because in an extractive setting, we copy, right? So the way we copy is we identify the candidate sentence. So maybe we can create some representations that can actually represent that that sentence is important, right? So maybe I have sentence one. I got some CLS representation, sentence two. I got another CLS representation, and then da. And then I can send all this to some linear layer, right? Right? And then maybe say that, oh, according to this guy, okay, this guy, okay, this guy, okay, right? So, of course, you guys are not trained to think like me, but I want you guys to learn to think like this. Otherwise, you don't, all the knowledge you learn in my classes are no use, right? But yeah, we can use encoder for extractive. How about for decoder? It's not so easy, right? It's not so straightforward. Well, we can do like this. Sentence one, and then put an extract token. Sentence two, and then extract token. And then sentence three, extract token. Like a prompt, right? Like a prompt. Like a very long prompt. And then say that, and then finally it will give me all the representations of each token, right? Because this is autoregressive. I get the EX1 and 2 and 3. Right, and then I send them to linear layer, right? And then see whether which one is important. Yeah. So this is possible, but I feel like in this sense, encoder is easier to manipulate, a little bit easier, right? Decoder encoder, can we do extractive? Maybe less useful. Why do we need to have two architecture when we can do with one, right? A little bit suspicious why you need to do the encoder decoder. Well, you can put the document into encoder and the decoder output which sentence is. It does not make sense a lot, right? So I mean, I will not try this one very early, right? But it's not say it's impossible. How about abstractive? Abstractive, which one? Tell me whether you understand my point. For abstractive, which one is impossible? Like impossible, you don't do it. Which one? You should already know. Yeah, correct. Everyone got it? Encoder, right? It's very clear. See my screen, okay. Press 2. No, that is, I should press 1. Okay. So they should see, they should look at this, right? Okay. Oh, this is not touch screen. Yes. Okay, anyway. Okay, great. So for the online students, you want to pin that panel, and then you can see it's not clear. You tried before. Uh, let me try. But where's the mouse? It doesn't work. Oh, such a good system. Okay, anyway, what I can do is I can write on the online. Yeah, I'm a little bit hesitant to write here simply because there's not much space, but I can do stop sharing and whiteboard, ending whiteboard. And so decoder, I need to share. It's already? Okay, great. So okay, I see flying pen. So what I did in the Blackboard is basically decoder, encoder, decoder, encoder, right? And abstractive and what? Extractive, right? And I just now say that this is probably possible and this is maybe possible, right? But I wouldn't want to think about this simply because it's too heavy, right? But for abstractive, encoder is impossible, correct? Because you want to say something, right? And encoder doesn't have the architecture to support that, right? Both of this is possible, right? Both of this is possible. So I want you to, by the way, this is an encoder decoder, sorry, right? And both of this is possible, very possible. Great. So once we think about the pre-trained era, then let's take a look at some of the key development during the pre-trained era, which influence how we do things. This one is for extractive. It's called bird sum, all right? And the idea is the only difference from bird that you can see is that usually for one sentence, there's always a COS. The next sentence also have a COS. The third sentence also have a COS. This is the difference between the normal bird and this bird. There's a COS. Why do you need to have COS? Because you want to choose the sentence that is highly useful, right? So you need to have representation of each COS. I hope that I point you the key point, right? The key essence of bird sum. And then once you do the bird, you will get the representations of these three guys, right? Then you can simply put them into linear layers and then see whether this is important or not, right? This Y could be the scores, right? That output whether those sentences are important or not. So this is bird sum. And again, this is also, if you try, this is a highly cited also, right? But it's only for extractive. So now people question, how do you do abstractive? And how do you do abstractive? And even until 2024 now, everyone is using mainly BAT. So even though this guy is 2020 in ACL, everyone do like this. So how do we do this? First, we do pre-training. All right, we do pre-training. So how do we pre-train? Well, we just send in some words. So we train an encoder decoder architecture. We mask some word, and then this could be the sentence, and then we ask it to try to predict the next token, right? So this is an encoder decoder. You please notice that A, B, C, D, E and A, B, C, D, E here is the same word, okay? So you just simply copy. You know. So it's a very simply pre-training mechanism. Does not need any pairs of X and Y. No. Now this bot, they also try token masking, sentence permutation, document rotation, token deletion, and text infilling. Everything I've talked here is pre-training, okay? Pre-training. How do they do fine-tuning? Very simple. In fine-tuning, they just use X and Y, right? Given the document, predict the Y, the summary, right? So please recall that during the pre-training, this is how the bot do things, but during fine-tuning, it's simply XY. Yes. Now, one thing that you may want to know about bot is which one is the most useful. And I want you to look at these two columns, XSum and CNNDM, which is a text summarization task. And if you look at that, for XSum, text infilling pre-training is the best, right? Right, the lowest perplexity. And for CNN Daily Mail, it seems like infilling and sentence shuffling is the best, right? What is my point? My point is that if you try to ask it to try to fill certain words in the mass, then it seems like it can ask the model to learn the knowledge much better. But in the industry, you don't need to know this because you will never pre-train a bot. You will never pre-train because you guys cannot pre-train. So then you simply take this bot and fine-tune, right? So I would say that bot is probably the leaders in summarization, but it's still not perfect. Even for Thai language, no, there's no hope. And also for all your Nepal, Indonesian, Myanmar, no. Trust me, no. Why? Why no? Our problem in Thailand, Myanmar, Nepal is we don't have data set. Yeah. The first step to start a model is data set. And data set is expensive, right? Yeah. But anyway, of course, they also compare with encoder base and bot, and they found that bot is always winning in all this summarization because they are hugely abstractive and they are mainly extractive, right? So that's why they are very good in producing very highly related summary compared to the ground truth summary. Okay, I think I'm over time. Why not we continue evaluation on the next lecture? Okay, see you on Wednesday. Thank you. Bye bye.